In this video, we are going to be looking at a very powerful feature of the Burp extension Hackvertor developed by Gareth Hayes. And that feature is the capability to introduce custom tags into the Hackvertor ecosystem with our own custom logic implemented with the magic of programming. This is a very, very useful feature that I've found has helped me out in many practical situations, especially weird behaviors and applications or complex workflows that needed a few hacks or tricks in order to properly navigate to test properly. Hackvertor has provided a really easy mechanism to make magic happen from time to time. And so we're going to take a look at how you can implement your own custom tags. Before you do that, of course, you need to install the Hackvertor extension through the Burp App Store, and then you also need to navigate to the Hackvertor menu and go to the settings dialog, because you need to make sure that you have the allow code execution tags enabled here. This is disabled by default for your protection, because enabling it, of course, allows the capability to inject custom code into Hackvertor, which of course could put you at risk. Well, we're going to take that risk, and we are going to be smart about it. And I recommend you do the same. Always run vetted code, yada, yada. You've heard it all before. The other important thing to point out is that you do need to have your burp settings pointing towards a valid Jython jar file if you're writing Python. And secondly, if you are writing Python, keep in mind that because it's using Jython within a Java environment, you are restricted to Python version 2. Python 3 is not supported by Jython. So before you start writing Python 3 and end up with all kinds of headaches and errors that are confusing and bewildering, just write Python 2. Okay, so let's create a custom tag. And of course, we will be using Python because it's simple and popular. You can also use JavaScript, Java, Groovy, and also AI, which we will not be using. So we're going to select Python under select language. And for our tag name, we're going to give it a very creative name of test1. We're going to ignore for now the arguments here. We'll come back to those later. We're just going to skip ahead to the code editor here. Now keep in mind, if you're doing anything complex, you probably want to use an IDE that is built for the purpose of writing code outside of Hackvertor. Of course, Hackvertor's editor is quite limited. I think in this environment, actually, it doesn't even support Control Z, right? So if I delete this and hit Control Z, no, my code's not coming back. So don't end up in that situation. Just add it somewhere else and paste it in when you're ready. Now let's take a look at the template code, which is quite important for our purposes. You can see that we have some predefined variables, output and input. This is what Hackvertor uses by default as the input, what your tag surrounds, and the output, what your tag is going to output to Burp once your logic has executed. You'll also see that there are a couple of comments here showing you that you actually have the capability to invoke other Hackvertor tags within your custom tag. We're not going to do this in that video, but that reference is there should you want to do that. So in the most simple case, we have some input that comes from what our tag surrounds, and we set that to our output. So if I go down to the test tag button here and I click that, anything that I write here, I'll say should come back to us unaltered. So of course, we don't have our tag implemented anywhere, so it's prompting us to specify what the input should be for this test case. And if I click OK, of course, we get a message saying should come back to us. It came back to us. Easy. Of course, we might want to do something a little bit more. So let's just do some string concatenation. I will just type test plus test, which I'm pretty sure is string concatenation with Python. And then to test the tag, I will click test again. I will write test, and then I will click OK, and our result is test test. It's as simple as that. You can also import Python libraries or modules. So just for another simple example, I'm going to import random here, and we will just create a simple random number generator. So here I'm going to set the output to just a random integer, and importantly, output is expected to be a string, so we're casting it to a string. Before we send that back, I'm going to click test tag. you can see that in this example, we're not actually using our input. It doesn't matter what the input is. I've just removed it entirely. You don't need to use it. And if you're just using a straight up random number generator, you don't need it. So the input here doesn't matter. We'll just get a random number. There we go, 75. Let's test it again to make sure that we get a different number. 14, success. Okay, let's create our tag and look at what it takes to actually use it. So I'm going to click Create Tag, and you don't see any clear indication that the tag has been populated somewhere, but we can view in the Hackvertor menu the List Custom Tags dialog. It'll show us our tag, test1. There it is. We can edit the tag. We can delete it. You can also import and export. Notably, I only see this in some Linux environments. Some of these dialog boxes get a little cut off. Luckily, in this case, it's still workable. Export all my tags to JSON file is what it looks like that final button reads. Just a side note, you might run into that. Not something we're going to look into or diagnose for the purpose of this video. So here I'm looking at Portswigger's Gin and Juice Shop. We don't really have a practical example to test with. This is just a nonsense example. We're just going to look at what it looks like in action. We don't actually have a specific goal. So I've selected the value of this CSRF parameter, and the easiest way to invoke our tag is to right-click and go to Extensions, Hackvertor, and then we can go to Custom, and we see our test1 tag. I click it, and now we have this tag that is introduced, and it's surrounding the original value that was in the CSRF parameter within the body of this HTTP request. There's one other thing to keep in mind here as well. We also have this new value that is introduced. So this value in particular, I forget the Hackvertor name for it, but it's a specific token that Hackvertor generates to ensure that this tag can execute, because it's an additional security feature to protect us from untrusted code, which could be injected into the environment. So it's basically saying, here's a token that was generated by Hackvertor, saying that, this tag is authorized to run. So let's say you had an environment where you set up tags to run on responses. In theory, an attacker could inject a tag and try to get that to execute custom code of their design. But if they don't have this token, they won't be able to do that. So it's a security mechanism. Hackvertor generates it by default. We don't need to think much about it. It's just, that's why it's there, just in case you are wondering. Just leave it. Don't touch it. I'll show you an example modifying it, that if you modify it, it does not run. But before that, let's see our tag actually run. So I'm going to go to send, and I click send, and that sends our request. And what you didn't see is you didn't see the processing of this. Our value doesn't change. The tag remains here. And that's actually the best way, in my opinion, for this to behave, because if it rendered our value right within this request, well, if we wanted to modify the base value, assuming we were using that as input and we were performing some type of translation, well, we would then have to go back, get that value, reinsert the tag. Here, it lets us modify that base value. It keeps our tag here. It doesn't render that. The consequence is we don't see what value is actually being sent to the server in this case. You normally would see that in a request. So in order to be able to inspect that, what we can do is we can go to Logger, and we can look at the most recent request that was sent. And if you look in the CSRF parameter value, you'll see that it generated a number. And to prove that we're generating random numbers, if I send another request and I go back to Logger and I look at the next request, look at that. It's another random number between 1 and 100. So our tag is working, and that's a very easy way to inspect the results. And of course, depending on what you're doing, you very well may need to inspect the results to determine, if you found an interesting behavior, if something happened that you didn't expect, you might want to go back and look at what you actually sent, and you might not always know from just looking at the tag itself. So let's look at another useful feature that we can do within custom tags. One thing that can be challenging if you encounter issues when you're implementing your own logic is diagnosing exactly what has went wrong. So we're going to create a new tag here I'm just going to call it, I don't know, error catch, I guess. And I'm going to make sure that it's Python again. And once again, we're going to keep this one simple. We're not going to use arguments. But what I'm going to do is I'm going to create this try except logic here. And this is very obviously intended to fail because in the try statement here, I'm setting the output to the results of this function intended underscore result, but I haven't defined that function. This function doesn't exist. And if I test my tag, like that will fail. We will see it fail. But crucially, what I'm doing here is I'm using output as an opportunity to catch the error and write it there. I found that sometimes this can just be a handy trick to actually see the error messages if your tags are actually failing in practice. It might be more work than you're willing to do, especially if you're writing very simple tags. There's really no need for this, but I'll just show you what that looks like. So I can create that tag, no problem. And what I'm going to do is I'm going to delete this. I'm just going to write the word test. I'm going to select it. I'm going to right click. I'm going to go to extensions, Hackvertor, all the way to custom, and I'm going to insert my error catch. You can see once again, we insert the essentially authorization token that allows our tag to execute. And if I click send, of course, we don't really care about the results. This is not really a practical example here. What we're interested in is seeing what the output of that is. So if I go to logger, I look in the history of requests here, we can see that we actually get the error message. Name intended result is not defined. So very easy way to see what our errors are. Of course, there is a side effect of your actually sending this request to the application. We're sending our error messages. Depending on what you're doing, you may not want to do that for one or more reasons. Maybe you have some maybe you have a very complex tag and you're calling some other API as part of the process, and somehow you inadvertently leak like an API key or something. That is theoretically possible. So just be aware of actually what is happening in the sequence of events, where data is going, and what the outcome is as far as requests being sent. So now let's look at a more useful example, and we'll look at one of the, we'll look at first, I think, the naive example, the naive way to implement it and do it, and then we'll look at a smarter way to do it in relation to one of the challenges that you might encounter. So let's go, once again, back to Hackvertor, create a custom tag, and I'm going to call this one Radamza. Radamza, I'm not really sure how that's pronounced. It's a very simple tool that allows you to take some input and mutate it. It's a very fun tool for fuzzing different inputs, especially if you just want to cause an odd condition or an error. It's a great tool for that. I have it installed on the command line. So if I type echo test and I send that over to Radamza, it will take that test as input and it will mutate it into something different every time I send it, just like that. And so we can use that tool. We can call that tool by sending our input to it, and we can get that output, and we can send that to the web application. If you've watched some of my other videos, you've probably seen me do this with other tools like Turbo Intruder. Using a Hackvertor custom tag is just a really easy way to integrate this directly within regular vanilla intruder to run really simple fuzzing attacks really quickly without the overhead of setting up Turbo Intruder attacks or doing anything else. So I'm going to cheat a little bit here in that, first I'm going to do that. Okay, I'm going to cheat in that I have the code ready to go, which I hope runs. We will find out. Of course, as with anything else, I'm going to paste the sample code. I'm going to put that on my GitHub within my YouTube folder, so you can grab that if you want to replicate these examples. Here, I'm just pasting this very simple example. So importing subprocess, which is allowing me to call Radamza on the command line. We're taking the output from that, and we're sending it back. It's basically as simple as that. And we don't have any arguments. We're just taking the input, running Radamza on it, sending it to the output. I can test the tag. Input is test. I click OK. And what do we get? we get an error. Okay, that's great. Where does the error occur? It shouldn't be here. Isn't this great? I see what I've done. I didn't set it to Python. That gets me very often. Okay, we're going to test the tag again, and hopefully there's no error that results. Our input is test here. I click OK. The output is just test, but if I run it again, we probably get something different. And look at that. Wow. What a test case here. It's going to mangle my UI completely. Okay, so there is a risk to doing this. Can I close this window like this? Okay, I can. That's great. So obviously it works. I'm going to create that tag. And what I'm going to do is I'm just going to type test back into this request again. I'm going to right click within it and I'm going to send it to intruder. And now what we're going to do is we're going to fuzz this value, hoping to cause some type of error or other interesting condition. And the way I'm going to do that is by right-clicking in that value, going to the oh, that's right. Another limitation of Hackvertor, which I probably have even mentioned in my last video. You can't access its menu within Intruder. So we have to set this up ahead of time. So back into Repeater, I'm going to right-click the value that I'd like to fuzz, and I'm going to go to Extensions, Hackvertor, Custom, and then I'm going to click Redamza. As you see, this is exactly what you expect. It inserts the tag. It inserts our token. It has surrounded our existing value of test, and now I'm going to send that to Intruder. And don't worry, even though the right-click context menu does not work correctly within Intruder, this will still get executed within Intruder. And what I'm going to do here is, of course, first it's going to make me create payloads. So I'm just going to create a payload just at the top here that's not going to do anything. I'm going to select null payloads. So that should just be empty. And I'm just going to send just 10 payloads to keep it simple. And we are going to just keep it as that. So the way this should work is this should fire off 10 times, which should cause 10 generations with Redamza, sending various test cases to our application, which hopefully causes interesting conditions that we can filter for within the Intruder results. So let's start attack. I click attack. Of course, I need to resume task execution, and there we go. That happened very, very fast. Now, the first problem you're going to notice, if we inspect the results of this, of course, we do have requests and responses here. Let me just maximize this for easy viewing. One of the challenges that you're going to see is that the Hackvertor tags actually do not get executed before the request is saved to the Intruder table. So we don't actually see what the payload is. However, if I go to Logger and I look at the traffic, we can see that this is all the traffic from the Intruder tool. You can see that the tag did work and those values were actually sent. The problem here is that, especially with Redamza, which the way that it works is by default, it grabs a random seed value. So each time it's using a random seed value, and in the request, without that information, we don't know what the seed is. So if we get a response that's interesting, it's very hard to map that response back to the specific request, determine what the payload is directly within Intruder. Of course, we could do that within Logger because we have those payloads, but it's a lot easier to just be able to do that within Intruder, have that all ready to go. So in order to create an improved variation of the Redamza custom tag, we are going to create yet another custom tag. This time, we're going to make use of arguments. So we can also introduce how arguments are used within Hackvertor. So once again, I'm going to the Hackvertor menu, I'm going to create custom tags. I'm going to make sure that I select Python as the first thing I do. I'm going to type Redamza2, and this time we're going to define an argument. And this argument is going to be a number, and I'm going to call it seed. So what we're going to do, because Redamza has the capability to supply a seed, I think it's just -s. We can test that. So let's say we supply the -s option on the command line, and I just choose a random number and I hit enter. The question is that going to produce the same result every time? It does. Okay, great. So -s is the parameter or the command line option to specify a seed value. When we specify this and don't change it, Redamza uses the same seed, and so it's a deterministic tool. I mean, it's always a deterministic tool effectively, but in this case, we can expect to get the same output from the same input here. And we're going to apply the same constraint on our new Redamza tag, and then what we're going to do is we're going to apply a seed using an iterator within intruder. Of course, we could also use a random number. We could do all kinds of things. But let's first set up our new custom tag. The default value here, I'm going to set as 1. And once again, I'm going to heavily cheat so you don't have to watch me write code in real time. And I'm going to copy the code that has been pre-made for this purpose. And if I click test tag this time and then click OK, we get test test. Now, in this case, we only get a prompt for specifying input. It doesn't give us a prompt for specifying a different value for that first argument. And therefore, every time I test this now, we should get the same output. So if I click test tag again, I get test test again. The reason being, I've specified the default value for the seed as 1. So it's using that -s as 1 each time. So I'm pretty happy with this. It works. I'm going to click create tag. And once again, I'm going to return to our default request. I'm going to type in test. Once again, I'm going to double click that value of the parameter. I'm going to go to extensions, Hackvertor, custom. I'm going to click Redamza 2. And you're going to see something a little bit different this time. Now you're going to see that our tag looks a little bit different in that we've introduced another parameter, and that is our argument. Which, by the way, actually, one thing I should mention real quick. So we'll go back and we will edit the Redamza 2 tag. I probably should have pointed this out. So I gave the parameter name seed to this argument, and that is how you use it within Hackvertor. You can see I'm just specifying seed here. As mentioned with the other scripts, I will be posting this one to my GitHub so you can find those if you would like them. Okay, so back to repeater. Now we have this set up to send to intruder. So I'm going to right click in here. I'm going to send it to intruder. Actually, before we do that, let me just demonstrate that we get the same value every time we send this because we have a static seed now instead of relying on Redamza to grab a random number to seed the operation. So if I send 2 requests, we should get that same test value in logger both times. And look at that. We do, right? So now to intruder. So what we need to do here in order to actually introduce some interesting test cases is we need to add our payload position. And here I'll just keep it very simple. I'll set it to basically just an iterating number from 1 to 10 with increments of 1. Very simple. And I think that's all we need. So I'm going to start the attack. And there we go. If we go and look at the requests, we're still going to see the same thing. We don't see what the actual payload is directly in intruder, but we do see what the seed number is. And that gives us a huge advantage because if we see an interesting response, which we don't because we don't have a real interesting example to work with, but if we did, we can now send this to repeater, and this is now deterministic. There's no randomness involved in this. This will send the exact same payload that was sent in intruder. And of course, we can always look at that what that payload works out to in logger as well. But this I found is a nice little trick to make this fuzzing directly within vanilla intruder a little bit easier using Redamza. And there are a few cases where I've had to use a trick like this to make things a little bit more workable. And in subsequent videos, I'll try to showcase some of those tricks and some of the workarounds to weird testing challenges that I have encountered and been able to solve with Hackvertor custom tags. But those are the basics. That's how you create tags. That's how you manage them. It's as easy as that.